All right, welcome to Chapter 1, Section 5. This is all about equations. So we need to know, can we understand what are the components of equations? Can we take the pieces and can we solve for variables? So before we worked on simplifying expressions, we worked on order of operations. Now we're going to be able to solve equations with one variable and two variables. So let's look at some vocabulary. We're going to see words like open sentence, obviously equation. We're going to have to solve those equations. We'll see some different solutions, and we'll talk about what kind of sets we'll see as we go forward. So our first example, we're going to see the phrase replacement set. So a replacement set, as you see here, is really just an option of potential answers for our expression. So given this equation here, we need to plug in each of these values and see which one is true. So that's the idea with the replacement set. They give us all these numbers to choose from. We plug them into our equation and see which one makes a true statement. So this part in blue, you need to write that down. So we replace A, like I said, with each value in our replacement set. So if we plug in a 2, this part you do not need to write. If we plug in a 2, what do we get out? Well, we get, after some multiplication, 8 plus 7 is 15. And 15 is not equal to 23. So when we plug in 2, this statement is a lie. It is false. So we know 2 does not work. Now we can check the next value. If we plug in a 3, what do we get? Well, 4 times 3 is 12, plus 7 is 19. That 19, now is this a true statement? 19, does that equal 23? Definitely not, so that's also a lie. If we plug in a 4, we see the statement is true. We get 16 plus 7, that's 23. 23 does equal itself. That is a true statement. So we know the number 4 in our set works. 5 comes out to be a lie. We get 27. That's not equal to 23. And 6 comes out to be a lie as well because 31 does not equal 23. So out of our whole replacement set, all of these 5 numbers here, the only number that works is 4. So 4 is true. Everything else is not. So what I need you to make sure that you have down for this problem is everything in yellow. The question at the top, and when we plug in 4, that we get a true statement. So just that piece there. 4 times 4 plus 7 equals 23, and 23 equals 23. That is true. So those two things please have down as we move past example 1 on to the next example. Therefore, we see the solution set is 4, and that's it, just 4. So 1b, we want to find the solution set for this expression here. So we've got 1, 2, 3, 4, 5 potential numbers to plug in. We can check those and see which one is true. So quickly, if I plug these in and do some mental math. So if I plug in a 0, I'll get 0 minus 5 equals 7. So let me get my pen here. If I plug in a 0, I get 6 times 0 is 0 minus 5, and that will equal 7. Now negative 5, does that equal 7? Definitely not. So 0 is out. That's wrong. If I plug in a 1, I'll get 6 times 1 is 6 minus 5. So I'll get a 1 on the left and a 7 on the right. 1 equals 7. Is that a true statement? No, it's not. So 1 is wrong too. If I plug in a 2, I get 12 minus 5. And I know that 12 minus 5 is 7. So I get 7 on the left. And I'll get 7 on the right. So is this a true statement? Well, yes, it is, of course. So 2 works. And I know if I plug in 3 and 4, the number on the left is just going to get bigger, and it's going to be bigger than 7. So the only number here that will work out of this whole set is the number 2. So of the available choices, we should get B, 2. And there we have it. Now let's solve example 2. So we see we need to look at this expression and pick the value that is true. So we've got 4 options here. We know we need to simplify everything on the left, and we'll get a number, and we'll see what this B value is equal to. So we've got 3 plus this whole quantity, so we need to multiply this out. If we do order of operations, we can do it. So first I need to know 2 to the third power. What is that? I know it's 8. Now we need to do what's in parentheses. 8 minus 2. I know that that's 6. So we've done parentheses and exponents. Now we can do everything else. Multiply and divide. 6 times 4. When I plug that in, I'll get a 24. So as I move to the next slide, 3 plus 24 will be the value for B. So when we solve that whole thing, B will equal 27. So if I go back, we had all of this here looking at our equation, and it all simplifies to 27 for B. So our answer is B, 27. Of our available choices, if we go back, B, 27 is correct with order of operations. So we solved that whole equation with a couple steps. Notice that it had only one variable. We will have problems coming up with more than one variable. So here we need to find the solution to this equation. So we need to solve for n. Here's our variable. They can pick any letter. It doesn't matter which letter it is. So there it is. We need to solve for that. We've got all this here to work with. So we need to find a way to get n by itself. So we need to just start by simplifying everything we can. So we evaluate the powers. We're doing PEMDAS, order of operations. 3 squared is 9. From there, we need to simplify what's inside of the parentheses. So 9 plus 7 gives me 16. And this is divided by n. So a number over n, we can write that as a fraction instead of using the division sign. This is the easiest way to do it. 16 over n plus 4 at the beginning. So we need to get n by itself. It's in the denominator. So one way we can get it out of the denominator is to multiply everything by n. So we multiply everything by n. That n in the denominator goes away, and we get 4n over here, 8n over here. Everything got multiplied by the value of n. Next, if we subtract 4n from both sides, because we want to get n by itself eventually, so we subtract 4 and 4. This one goes away. We have just 16 on the left. And with one final step, we can get rid of the 4 attached to this n and finally get it by itself. And the way to do that is to do the opposite of multiplication. So since these two things are tied by multiplication, we need to divide away the 4, and n equals 4. So we've now solved that whole equation for our variable, and there we have it. Now let's look at 3b. So we need to solve this equation for n. We've got it on both sides of the equation though. So if you notice, there's an n on the left and an n on the right. We need to solve and get all the n's alone. So if we start with our original equation, we've got that. If we use the distributive property, we can apply the negative to both of these terms. So we get a negative 12 here and a negative 2 here. Now if we go to the right, we have an n that needs to be distributed to both of these terms. So if you notice here, n times 6 becomes 6n. N times a negative 2 becomes negative 2n. and then we have the negative 9 at the end. Now what do we need to do? Well, we need to combine all these like terms. So I've got 6 n's minus 2 n's. That's just going to be 4 n's. 6 minus 2 is 4. On the left, negative 12 minus 2 becomes negative 14. So now we have 4n minus 14 equals 4n minus 9. Now, since we have the same number of n's on both sides, those are going to cancel out. So say I subtracted 4n from both sides, they would both disappear, and we would be left with this expression here. Now, is this a true statement? Does negative 14 equal negative 9? Well, we know it doesn't. Those are two numbers that are definitely unequal. So we know that this is a lie. This is not a true statement. Whenever you're solving your equation and you get something like this that is not a true statement, then you know that there is no solution. So that's a special case where no matter what value of n you put into this whole expression, it will never be a true statement. There's nothing that could make it true. So the equation will never be true. The answer is then no solution. So moving on to example 4, we're looking at identities. So we'll learn a little bit about another special case when we come to equations. So we need to simplify this thing. So we'll start by distributing our 3 to the k into 32 right there, as well as doing what's in parentheses on the left. So 8 divided by 4 becomes 2. 5 plus 2 becomes 7. So the left side is looking good. Now if we move to the right side, 3 times k and 3 times 32 becomes 3k plus 96. Now we've got some other things here we can combine. So if we subtract 96 and 89, we get 7. Now notice we have 7 plus 3k on the left, and we also have 7 plus 3k on the right. So whenever you end up with an equation that has the same things on both sides being equal, and your variable is still there, that is a true statement, and it is always true no matter what value of k you put in, right? I could put in a 0 here and you would get 7 equals 7. That's true. I could put a 1 in here and you would get 10 equals 10. That's true. So it doesn't matter what value of k you put in there, any number, it will always be true. So this is like the opposite of what we just saw before. The equation will always be true. So the answer then is all real numbers, or any real number. So you can write all real numbers if you see this on a quiz, on a test. Another way to say all real numbers is to do the R with a line, with a second line on the left side, just like that. All real numbers. Now example 5. So here we've got a couple sentences to write down. So as you're doing that, we need to pay attention to, let's talk about what this problem is about. So remember, you only need to write what's in blue. So do that quickly as we talk about the problem. So someone named Dahlia is interested in a gym membership. Lots of people go to the gym, but those things cost money. So she pays $16 each month for the membership. She also pays $2 for a Pilates class. So I'm going to circle the things that I think are important. So $16 each month, that's important. And the $2 for each Pilates class, that's also important. So those two numbers are going to come into play. We need to write and solve an equation to find the total amount that Dahlia spent this month if she took 12 Pilates classes. So 12 Pilates classes, also very important. So we need to use those numbers and the context to understand what the cost is going to be for Dahlia. So we know the cost of the gym membership is a flat rate. She pays that every month. Every month she pays $16. The variable is the number of Pilates classes she attends. So every time she goes to another Pilates class, she has to pay $2. Okay, so that's a determining factor in how much she's going to spend on going to the gym. So the total cost per month for the gym membership, or the total cost for going to the gym in 1 month, is going to be the price of the gym membership, $16, plus 2 times the number of Pilates classes that she goes to. Why 2 times? Because each class costs $2, right? 1 class would be $2. 2 classes would be $4. 12 classes would be 12 times 2, which is $24. So if we wanted to write an equation, we could do that. So C is the total cost. That's equal to 2 times P, the variable for the number of Pilates classes she takes, plus the flat rate for the gym membership, 16. So right here where it says write an equation, this is our equation. We wrote the equation. Now we need to solve the equation using the number they gave us. So we know P in this example, the number of classes she attended, is 12. So we can substitute 12 for P in our example. So if we do that here, we see that P becomes 12. 2 times 12 we know is 24. And 24 plus 16 in your head or in a calculator is 40. So the total cost she spent this month going to the gym is $40. So this example involves a couple variables, so we can use our math skills to solve it if we take it step by step. So the answer there, Dahlia, her total cost for the gym is $40. That's all of the examples for equations 1.5 in your book. We're moving on to bigger and better things, so please let me know if this is too complex, if you need more help. This is the time to clarify, as things are simple before they get too difficult.